Picture this. You're sitting in the exam hall. The clock is ticking down. You've got exactly 90 minutes to glory. 90 minutes to prove everything you've worked for. Okay, let's dive into this explainer and build your absolute ultimate game plan for mastering Cambridge, AS, and A-level mathematics. Specifically, Syllabus 9709. Welcome to the session, everyone. I'm your host, your strategist for today, and we are tackling a topic that is literally the heavyweight champion of the examination hall. We're talking about energy, work, and power. More specifically, we are zeroing in on gravitational potential energy and kinetic energy. But listen, if you're expecting a basic textbook read-through where I just point at formulas and nod, you're in the wrong place. We aren't just going to look at equations today. We are going to deconstruct exactly how Cambridge examiners evaluate your understanding of these concepts under extreme pressure, and how you can strategically structure your answers to guarantee maximum marks. We're treating this like the championship final it is. Whether you're stepping up from IGCSE 0580 or 0606, or you're making the jump from O-level 4204, 4307, or 4040, this 9709 syllabus is an entirely different beast. It demands a totally different mindset. So let's get your head in the game. We are starting right out of the gate with the ultimate stakes. Look at this quote. This comes straight from the senior examiners themselves. The difference between a B and an A in mathematics often comes down to how well you understand energy, work, and power. Let that sink in for a second. This is the exact topic that separates average marks from absolute, undeniable mastery. It is the crucible. Now, I want you to imagine two different students taking this exam. Let's call them Alex and Sam. Alex is the kind of student who overloads every single answer with raw mathematical facts. Alex memorizes every formula, dumps them all onto the page, but completely ignores the actual analysis. It's just a wall of numbers with zero context. Then you have Sam. Sam knows this stuff, but constantly rushes. Sam speeds through the paper, entirely missing the specific requirements of the command words, calculating when the paper says, show that, or describing when the paper says, evaluate. When the examiner gets Alex and Sam's papers, it's just a sea of red pen marks. Why? Because this exam tests so much more than your ability to remember an equation. It tests your logical reasoning, your patience, and your analytical depth under intense pressure. You want the green check marks. You want that A star. That's what we're going to unlock today. Here is our tactical masterclass agenda to systematically conquer gravitational potential energy and kinetic energy problems. We're going to rapidly move through the ACE difference, core mathematical principles, the method mark strategy, top examiner traps, and finally, the ultimate deconstruct, solve, evaluate framework. Let's get straight into it. Section 1, the A's difference. This is all about unlocking your elite potential. To secure those elite, top-tier grades, you have got to understand that applying these formulas to totally unfamiliar contexts requires rigorous step-by-step reasoning. Look, we all know the absolute basics, right? Gravitational potential energy is mass times gravity times height. Good old MGH. Kinetic energy is 1/2 mass times velocity squared, 1/2 mv squared. Easy. But here's where students like Alex completely fall apart. The Cambridge assessment objectives target highly distinct cognitive domains. They are looking for knowledge, sure, but way more importantly, they are hunting for application and analysis. The conceptual framework here draws on established principles that demand systematic analysis and evidence-based mathematical reasoning. You literally cannot just plug numbers into a calculator and hope for the best. You have to prove, on the page, why those numbers belong there in the first place. Are you dealing with a smooth surface or a rough surface? Is mechanical energy actually conserved, or is work being done against friction? You have to state these principles before you even touch your calculator. Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now, because mastering this level of evidence-based reasoning is exactly what we train you to do every single week. Moving on to Section 2. Core mathematical principles. We are talking about depth over breadth. Standard study habits totally rely on a superficial breadth of knowledge. Average students, like our friend Alex, try to memorize every single possible variation of a past paper question. It's an impossible task, but the syllabus explicitly emphasizes that top-performing students exhibit a connected conceptual understanding. Examiners don't just want you to memorize formulas, they demand analytical depth. They want you to take the core principles of energy and work and transfer them seamlessly to completely unfamiliar contexts. Now, let's talk about Sam again. Sam rushes and misses command words. In Cambridge exams, command words are everything. Calculate, determine, show that, justify. If the question says, show that the velocity is 5 meters per second, and Sam just writes v equals 5, Sam gets 0 marks. 0. You have to use a framework. For essay subjects, they use PEEL, point,
evidence, explanation, link. But guess what? Top math students use a variation of the Peel framework too. Point, state the principle, like conservation of energy. Evidence, write down the base formula, mgh equals 1/2 mv squared. Explanation, substitute your specific values into the formula with clear working. Link, logically link your final calculated value back to what the command word actually asked for. That adaptability, that structured approach, is the true hallmark of an A-star student.
Section 3. The Method Mark Strategy. In Cambridge 9709, process is power. Top-performing students follow this exact 5-step procedural framework to develop professional skills and ensure absolutely no marks are left on the table. Let's visualize the transformation here. Let's take those red pen marks from Alex and Sam's papers and turn them into green check marks. Step 1, you deconstruct the question. What is the command word? What is the physical scenario? Step 2, extract the relevant data. Literally write down m equals 5 kg, h equals 10 m on the side of your page. Get it out of the dense paragraph. Step 3, select your analytical framework. Are we balancing kinetic and potential energy? Is there a driving force doing work? Step 4, execute with clear, precise notation. Step 5, present your final answer with the correct terminology and proper formats. Let's do a mental 60-second rewrite right now. Imagine a question. A block of mass 4 kg slides down a rough slope. Calculate the work done against friction. If you just write a bunch of numbers in an answer, that's a red mark. If you write initial GPE equals mgh, final KE equals 1/2 mv squared, work done against friction equals initial GPE minus final KE, and then you substitute your values, boom, green check marks all the way down. You are building a mathematical success blueprint on the page. Stop scrolling. Subscribe to our YouTube channel, AC Exams, at acexams_IGSC to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acexams_IGSC and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, I need your full attention right now. Heed this massive examiner alert. This is arguably the most important takeaway from this entire explainer. Students constantly lose marks by not showing their working. Your process is literally a lifeline. Let's do a quick interactive workshop right here. Challenge 1, data scan. I want you to imagine a complex data table on your screen showing different masses, initial velocities, and final heights. You've got 60 seconds on the clock. What's the core trend? The core trend you need to extract is always the relationship between kinetic energy lost and potential energy gained. Challenge 2, find the flaw. Listen to this hypothetical student working. Velocity is 10, mass is 2, so kinetic energy is 100. Potential energy is also 100, so height is 5. Did you catch the flaw? The student didn't state the formulas, didn't show the substitution of 1/2 times 2 times 10 squared, and didn't state that they were assuming conservation of mechanical energy. If you follow the procedural framework we just discussed and write down every single logical step, you secure method marks. Even if you make a silly calculator error at the very end and your final numerical answer is completely wrong, a clear, logical process can save your entire grade. Examiners award marks for the method. Show them how your brain works.
Section 4. Top Examiner Traps. We are going to expose the top 3 mistakes so you never make them. Looking directly into the principal examiner reports, here are the top 3 traps that catch hundreds of students every single year. Number 1, using the wrong approach for the wrong context. This goes right back to our earlier point about connected understanding. If you apply a standard mgh formula to a complex system, but you forget that there is a driving force from an engine, or you ignore air resistance when the question specifically told you the surface was rough, you've fallen into the trap. You used a conservation approach when you needed a work energy principle approach. Number 2, forgetting to check format and presentation conventions. If you leave out your standard units, writing just 50 instead of 50 joules, or if you don't state your assumptions clearly, you hemorrhage marks unnecessarily. Number 3, providing answers that are not specific to the context given. Let's do challenge 3, speed writing. You have 30 seconds to write a perfect paragraph in your head. If the question asks, why does the actual velocity differ from the calculated velocity, you cannot just write because of friction. You need to be specific. Work is done against frictional forces along the rough plane, which converts some of the initial gravitational potential energy into thermal energy, resulting in a lower final kinetic energy. Boom. That is an A-star answer. Avoid these 3 specific pitfalls, immediately elevate your presentation, and you will instantly stand out above the average candidate. Section 5. Deconstruct, solve, evaluate. This is the final framework. This is your ultimate bulletproof problem-solving framework. It comes down to 3 overarching rules that guarantee top marks: command word decoding, Peel framework application, and the time management matrix. Let's break it down into these 5 actionable steps. Step 1, identify the given information. That's your data extraction. Step 2, break the problem into logical steps. That's setting up your equations. Step 3, solve systematically, showing every single line of working for those precious method marks. But listen to me, it's steps 4 and 5 that secure the absolute highest grades, the ones that push you into the 90th percentile. Step 4, check for reasonableness. Look at your final velocity or your final energy value. Does it actually make physical sense in the context of the real world? If a 2-kilogram mass dropped from a height of 2 meters is suddenly calculated to be traveling at the speed of sound, you know you've made a terrible mistake. Don't just leave it. Go back and check your algebra. And step 5, evaluate your system. By evaluating assumptions and checking for reasonableness step by step, you prove to the examiner that you don't just know how to push buttons on a calculator, you truly understand the physical, mechanical system you are analyzing. You've mastered the matrix.
So the ultimate question is, are you ready to actually apply this mindset? You now know exactly what the Cambridge 9709 examiners are looking for. They want depth over breadth, they want those method marks secured through crystal clear working, and they want you to evaluate your final answers for real-world reasonableness. Take this tactical blueprint, apply it directly to your very next set of past paper questions, and focus intensely on your process. Master the method and you'll lock in that A-star. Students who implement these mathematics strategies see an average improvement of 2 great boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Go get that A-star.